Rules of exponents. The expression 5 cubed is an exponential expression with base 5 and exponent 3. It tells you to multiply 3 factors of 5 to get 5 times 5 times 5, or 125 in simplified form. You might recall the order of operations. You might have learned PEMDAS. I'm not a big fan of PEMDAS because you sometimes think that multiplication comes before division and addition comes before subtraction. Again, PEMDAS stands for parentheses, exponents, multiply, divide, add, subtract. But in reality, multiplication and division occur left to right, or they're calculated left to right as they occur in the problem. Same with addition and subtraction. Addition doesn't necessarily come before subtraction if subtraction is first in the problem. So the order of operations, step 1 is to simplify inside the grouping symbols. Step 2 is to evaluate exponents. Step 3 is multiply or divide in order from left to right. Step 4 is add or subtract in order from left to right. Example number 1. The base is -4 and the exponent is 2. So if we would write this out, this is -4 times -4, which is equal to 16. Number 2 is very different. This is the opposite of 4 squared. You need to calculate the exponent first, which is 4 squared, which is 4 times 4. 4 times 4 is 16, and the opposite of a positive 16 is a negative 16. In other words, your base is 4, your exponent is 2. You calculate that, and then you take the opposite of that. Please notice the work is very different from number 1 to number 2. 1, your base is -4. It's -4 times -4. Number 2, your base is 4. It is 4 times 4, and take the opposite. Keep this in mind if you're using your calculator and you want number 1, however, you put it in your calculator like number 2. All right, number 3. First, we need to calculate exponents. So we can take 3 to the 4th, which is 81, plus 4 times 2 cubed. Your base is 2, your exponent is 3, and 2 cubed is 8. Next, we're going to multiply 4 times 8, and we get 32. And now we'll add 81 plus 32. Number 4. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 3 cubed. 3 times 3 is 9. 9 times 3 is 27. Next, we're going to do division. 27 divided by 9 is 3. And 16 minus 3 is 13. All right, I want to take another look here at number 1 and number 2, and look what happens if we have odd exponents. So if we have -4 cubed, again, our base is -4, so that would be -4 times -4 times -4, which is -64. If we have it written with the negative and then the 4 and then the cubed, this is the opposite of 4 cubed. So this would be -64 as well, but notice the work. The work is different. When the base is in parentheses, you have the base times itself that many times. if the negative is out in front, then it's not attached to the base. Even though we get the same answer, just know the work is different. All right, let's move on. The expression x cubed is an exponential expression with the base x and the exponent of 3. It tells you to multiply 3 factors of x to get x times x times x, or x cubed in simplified form. Let's look at the pattern we have here. 5 to the 4th is 5 times 5 times 5. Did I say it 4 times? 5 times 5 times 5 times 5, which is 625. 5 cubed, 5 times 5 times 5, which is 125. 5 squared, 5 times 5, which is 25. 5 to the first would be 5, which would just be 5. How can we use this pattern to figure out what 5 to the 0 would be? Well, if you look at the factors, if you look at the second row, you've got 5 times itself 4 times 3 times 2 times 1. Well, that would make sense. In the next column, we wouldn't have anything. And then if you look at 625, 125, 25, there's kind of a pattern if you notice. If you take 625 and divide it by 5, you get 125. If you take 125 divided by 5, you get 25. If you take 25 divided by 5, you get 5. So it makes sense if we look at this pattern that 5 divided by 5 is 1. So I just went through all this to basically state that anything to the 0 power is 1. And if we continued this pattern and we said, well, the next pattern would be 5 to the negative first, and the next one would be 5 to the negative 2, and we continued this dividing 5 pattern, then we could figure out that 5 to the negative first would be 1/5. If we take 1/5 divided by 5, we get 1/25. And not to worry, that comes in a different lesson. But while I'm doing patterns, I thought I'd just keep going. All right, so our big thing here is any number except 0 to the 0 power is equal to 1. All right, so let's evaluate some. -4 to the 0 is 1. X to the 0, provided x doesn't equal 0, is 1. 3 times -2 to the 0, well, -2 to the 0 is 1. So this is 3 times 1, which is 3. And number 4, we have a base of 5x squared y to the 5th. All of that is to the 0 power, which is 1. So here's my funny. What would 4 cats to the 0 plus 5 dogs to the 0 equal? Well, if you answered 9, you have it correct. This would be 4 times 1 plus 5 times 1, which is equal to 9. Just remember, although the variables spell animals, which you're familiar with, anything to the 0 power is 1. All right, moving right along. Rules of exponents. The first one that we're going to learn is called the product rule. If you have a to the m times a to the n, that is going to equal a to the m plus n. This says that to multiply two exponents with the same base, you keep the base, add the exponents. So repeat after me. Same base, multiplying, keep the base, add the exponents. One more time. Same base, multiplying, keep the base, add the exponents. All right, so let's apply it. Number 1, 2 cubed times 2 squared. You have the same base, which is 2. We're going to keep the base. We're going to add the exponents. This would give us 2 to the 5th, or 32. Now, if you forget the rule, you can always use the definition of exponents. 2 cubed is the factor of 2 written 3 times, times 2 squared, which is the factor of 2 written twice. Now you can count up your 2's. You can see that you have 2 times itself 5 times. So either way, by using the definition or the rule, we're going to get 2 to the 5th, and 2 to the 5th is equal to 32. Number 2, same base, multiplying, keep the base, add the exponents. Recall that there's a 1 as an exponent if it's not written. So we have x to the 4 plus 3 plus 1. That gives us x to the 8th. Number 3, we can multiply in any order. Multiplication has a commutative property. So if I decide to write this, putting the numbers first and the exponents second, then I'm going to multiply 3 times 6 and get 18. X squared times x to the 5th, same base, multiply and keep the base, add the exponents, and 2 plus 5 is 7. Number 4, we're going to use our distributive property because we cannot combine like terms inside the parentheses. So I'm going to multiply negative 2x times 3x squared. 2 negatives will make a positive. 2x times x cubed. So I have negative 2 times 3 is a negative 6. X times x squared, same base, multiply and keep the base, add the exponent. Plus 2x times x cubed would be x to the 4th. Take a look at the second rule we have. Power of a power rule, which says if you have a to the m raised to the nth power, you're going to multiply the exponents. That would equal a to the m times n. This says a power to a power, you keep the base, multiply the exponents. So repeat after me. Power to a power, keep the base, multiply the exponents. All right, let's try it out. 3 squared to the 4th. If we use our power of a power rule, we're going to multiply the 2 times the 4. And that's going to give us 3 to the 8th. But if you forget the rule, you can always use your definition of exponents. 3 squared to the 4th. The 4th power means you have 3 squared times itself 4 times. Then you can break each one of these down. And then you can count up how many factors of 3 you have. And you have 8. I would encourage you to practice the exponent rules because they're going to come in super handy. All right, number 2, a to the 4th raised to the 5th power. We have a power to a power. We'll keep the base and we'll multiply 4 times 5, and that'll give us a to the 20th. Number 3, the x squared is raised to the 5th power. So we need to do that first. So 2 times 5 is 10. Now we're multiplying. So we have 4 x times x to the 10th, same base, multiplying, keep the base, add the exponents. 1 plus 10 is 11. And number 4, 1 cubed raised to the second power. Power to a power, we multiply. So that's 1 to the 6th, and 1 to the 6th is just 1. Next rule, power of a product. Product means we're multiplying. So now we have a product, AB, that's being raised to a power of n, which means we have to take the power to each factor of the base. Keep in mind, you're going to have to use multiple rules at the same time. So here we go. xy to the 4th. If we use our power of a product rule, that is going to give us x to the 4th, y to the 4th. If you would prefer to write it out or just use the definition, I can show you why this works. If you have xy to the 4th, that means you have xy times itself 4 times. And then if you group your x's together, group your y's together, you can see that you have x to the 4th, y to the 4th. Number 2, 2a to the 4th, all of that is raised to the 3rd power. So we're going to take the 2 to the 3rd power. Now we have a to the 4th to the 3rd power. Now you're going to have to use your power of a power rule. So we have 2 cubed, and then 4 times 3 is 12. So this will give us a to the 12th, and then 2 cubed is 8. So we have 8a to the 12th as our final answer. Number 3, the base is negative 5x, and that is being raised to the 3rd power. So we have negative 5 cubed times x cubed. Negative 5 cubed is negative 5 times negative 5 times negative 5, which is negative 125 x cubed. All right, number 4. We need to take the power to each factor inside. So we're going to have negative 3 to the 4th, x cubed to the 4th, y to the 5th to the 4th. Negative 3 to the 4th will be 81. We're going to use our power of a power rule here. We're going to multiply 3 times 4 and get x to the 12th. And then y to the 5th to the 4th, power to a power, we multiply, and we get y to the 20th. I'm trying to write out all my steps so you can see what you're doing, but if you can go from the original problem to the answer, that is fine. All right, let's look at another rule. Power of a quotient. Quotient is division. So you have a base that is division and you have a power. So you need to take that power to everything in the numerator and everything to the denominator. And again, be ready to use more than one rule at a time. So we have 2/3 to the 4th. So that's going to be 2 to the 4th over 3 to the 4th. 2 to the 4th is 16. 3 to the 4th is 81. And again, if you wanted to use the definition, that's just 2/3 times 2/3 times 2/3 times 2/3. Number 2, 5 over x to the second power. We should state here that x cannot be 0 because you can't divide by 0. So this would be 5 squared over x squared. Which will give us 25 over x squared. Number 3, again, it should say in the problem that y cannot equal 0. So we're going to use our power over quotient. We've got x to the 12th over y to the 12th. And number 4, we're going to have x plus y cubed over 5 cubed. X plus y is a binomial, which we'll get to. You cannot take that power of 3 and do anything else with this problem because our rules are only for powers of a product, and x plus y is not a product. So our final answer would be x plus y cubed over 125. Simplify each expression using exponent rules. I would encourage you to turn off the video and see how far you can go without my help, and then turn it back on and see how you did. Number 1, we have x squared times the opposite of x cubed to the 4th. You could also think of this as you're taking a negative to an even power, which would make it positive. So there's several different ways to think about that. So we have x squared. Power to a power, you're going to multiply. So this is going to be a positive x to the 12th. Same base multiply and keep the base, add the exponents. You get x to the 14th. Number 2. If I write out all my steps, I'm going to have 5a squared over b cubed squared. I have a product, 5a to the power of 2. So that's going to be 5 squared a squared over power to a power and multiply and get b to the 6th. Simplify this. We get 25 a squared over b to the 6th. Number 3, we have a quotient, we have a power. We're going to take 4x squared cubed over 3y cubed raised to the 3rd power. Then we have to use several rules here. We have our product, 4x squared cubed. So we have 4 cubed, and then we have x squared cubed. So that's going to be 2 times 3. Same in the denominator, 3 cubed y to the 3 times 3. So I have 64 x to the 6th over 27 y to the 9th. Number 4, power to a power I multiply, a to the 6th times, I can write this as negative 2 to the 4th times a cubed to the 4th negative 2 to the 4th is going to give me a positive 16. I have a to the 6th times a to the 12th. Same base, multiply and keep the base, add the exponents, and 6 plus 12 is 18. Number 5, I'm going to use my product and power to a power rule here. I'm going to go ahead and multiply them. So a squared cubed is 2 times 3 is 6. B to the 4th cubed, power to a power you multiply, you get 12. B to the 12th times, we have a negative to an odd power. So I can write that as negative 1 cubed. A cubed cubed, power to a power you multiply, you're going to get a to the 9th. And b squared cubed, power to a power you multiply, you're going to get b to the 6th. So when I evaluate negative 1 cubed, that's going to give me a negative. You can put your 1 out in front or you don't have to. Then I have a to the 6th times a to the 9th, same base, multiply and keep the base, add the exponents. So that's a to the 15th. B to the 12th times b to the 6th, same base, multiply and keep the base, add the exponents, and 12 plus 6 is 18. Either one of those answers are correct. Number 6, we have a negative to an odd power. You can write it as negative 2 cubed. You can write it as negative 1 cubed times 2 cubed, but I think this is easier just to go with negative 2 cubed. X squared cubed. Anything to the 0 power is 1, so I'm not even going to include the y anywhere. And then z to the 5th cubed. Negative 2 cubed is negative 8. Power to a power you multiply. This gives me x to the 6th. Power to a power you multiply. Z to the 15th. Number 7, power to a power you multiply, y to the 6th. Power to a power, 4 times 3 is 12, so that's x to the 12th, y cubed. Same base, y, multiplying, keep the base, add the exponents. So this would be x to the 12th, and 6 plus 3 is 9, y to the 9th. Number 8, you have the same base. Your base is x plus 5. Same base multiplying, keep the base, add the exponents. So that would give us x plus 5 to the 21st power. And as a little extra bonus here, keep in mind that if you have like x plus 2 times x plus 2 to the 20th, that there's a 1 if it's not written. So this would be x plus 2 to the 21st. All right, number 9. We're going to distribute. So we're going to have 3x squared times 4x squared plus 3x squared times 2y. 3 times 4 is 12. X squared times x squared is x to the fourth. 3 times 2 is 6. X squared y. Number 10, you can distribute the way it's written, but I prefer to have my x to the fourth y cubed in the front. But again, it doesn't matter. So I'm going to distribute. So I'm going to have x to the fourth y cubed times 7x minus x to the fourth y cubed times 3y. And if it helps to put this in parentheses, go for it. So the first term we have 7, x times x to the fourth is x to the fifth, y cubed minus 3x to the fourth, y cubed times y is y to the fourth. All right, next here's your summary of rules. So now we're going to go on to 5.2, adding and subtracting polynomials. Well, if we're going to add and subtract polynomials, we should probably know what the word polynomial means. So a monomial is a number, a variable, or a product of a number and variables raised to natural number power. Well, we need to know what natural numbers are. Natural numbers do not include negatives or zeros. Natural numbers are 1, 2, 3, 4, 5. An example of natural numbers. So, example of a monomial could be 4. It could be x. It could be 4x to the fifth, y to the 10th. All of those are monomials. A number, a variable, or a product of a number and a variable. A polynomial is a monomial or a sum of monomials. And I mentioned before that the x plus y was a binomial, which is down here, which I'm getting to, but a polynomial is like the big umbrella. So polynomials could be x squared plus 42. It could be x plus y plus z. It could be w plus 7 plus y plus a plus c. You get the idea? Polynomial is just a big umbrella. And we can break it down further into a binomial and a trinomial. So a binomial is a polynomial with 2 terms. So x plus y. Bi means 2. So we got 2. We could have x squared plus 4. We could have x plus y squared. The idea is you have 2 terms. And then a polynomial that has 3 terms is called a trinomial. Tri meaning 3. So that could be a plus b plus c. It could be 4x plus 5y plus 10. So a polynomial isn't just a general term. Then you have a monomial, which is 1. You have a binomial, which would be 2 terms, and a trinomial, which would be 3. And after that, we usually don't classify polynomials after a trinomial. We just say they're polynomials. Okay, two monomials with the same variable raised to the same power are like terms. So examples of like terms would be 7x squared and 6x squared. Those are like terms. Negative 3y and 5y are like terms. 2x squared y and 5x squared y are like terms. To add two or more polynomials, you can combine the like terms by adding the coefficients. So my examples above, we could take 7x squared minus 6x squared. They are like terms. All right, we're adding, so I better make it an addition problem. We can take 7 plus 6 and add them and get 13x squared. You do not change the variable or the exponent. In order to be alike, the variable and the exponent have to be the same. Negative 3y plus 5y. We can add those. They are like terms to get 2y. 2x squared y plus 5x squared y. We can add the 2 plus the 5 and get 7x squared y. So you have to keep multiplication with exponents is different than adding or subtracting. To subtract one polynomial from another, add the opposite of the second polynomial to the first polynomial. Find the opposite of the polynomial. So 4x to the 7th, the opposite of a positive 4x to the 7th would be a negative 4x to the 7th. If we want to find the opposite of this trinomial, this means we are taking the opposite of negative 2x squared plus 3x minus 5. That means you're going to change all the signs. So the opposite would be a positive 2x squared minus 3x plus 5. All right, let's practice. We can take the parentheses off here, and we're just going to combine like terms. So our like terms are 3x minus 4x, and you could put plus negative 4x if you wanted, plus 5 plus 4. So 3x minus 4x is negative x, and 5 plus 4 is 9. Number 2. The parentheses here are just showing you that you have a trinomial plus a binomial. So I would consider rewriting this with your like terms together. And if I combine like terms, 3x squared plus x squared is 4x squared. 4x plus 4x is 8x. And then plus 1. Number 3, I'd take the parentheses off and rewrite it with the like terms together. So that's 2x squared plus 5x squared minus 3x minus 4x minus 6 plus 8. So I have like terms. Negative 2 plus 5 would be 3. They have the like x squared, so we have 3x squared. Then I have negative 3x minus 4x, negative 7x. And then I have negative 6 plus 8, it's positive 2. All right, now I got to pay close attention here, and I got to match up the like terms. So I'm looking for an x cubed y squared. So this is a 5x cubed y squared. This is a negative 5x cubed y squared. So one's positive, one's negative. They're going to make a 0. So then I just have 3x squared y cubed plus 8 squared y cubed. So I can add 3 plus 8 and get 11. Now let's subtract. When you subtract, you're going to add the opposite, or you're going to distribute the negative. So the parentheses have an effect on the parenthesis behind it. The negative has to be distributed so that we are subtracting. So this would become a positive x and a negative 3. Now, when I combine like terms, I have 4x minus 2. There, that helps. Number 6. X squared minus 4x plus 7. Now we need to subtract the trinomial that's in the back. So we're going to take the opposite. So it's a minus 5x squared, a positive 4x, and a minus 7. If I put my like terms together, I combine x squared minus 5x squared, that's negative 4x squared. Negative 4x plus 4x makes a 0, and 7 minus 7 makes a 0. So there we go. All right, number 7. Three x squared minus 2x minus 5x squared minus 4x minus 2. You can group your like terms together if you'd like. And combine like terms. 3x squared minus 5x squared, negative 2x squared. All right, number 8. Put it all together in one nice big long problem. What we have is a trinomial plus a trinomial minus a trinomial. Watch your signs. I would encourage you to try it on your own and then play the video. So there we go. All right, number 9. Evaluate the polynomial expression for each value of x. Use your brain and not your calculator to do these, and then check it on your calculator. If we want to substitute in x equals -2, whenever you plug in a variable, a number for a variable with an exponent, put it in parentheses. The base is -2 and it is squared. This is a +4. Minus a -2 makes a +2 plus 3. 4 plus 2 is 6. 6 plus 3 is 9. We have x is equal to 3. I am still going to use parentheses anytime I plug a number in for a variable. Three squared is 9. 9 minus 3 plus 3 gives me 9. All right, I would encourage you to try this one on your own and then start the video to see if you're right. All right, well, if you got -93 when x is equal to -3, congratulations. And when x is equal to 1, the expression is equal to 3. All right, number 11. Write a polynomial that gives the area of a rectangle. First of all, we know that the area of a rectangle is equal to length times width. So if we look at the side that I've highlighted in yellow, if the tan side is 8 and the blue side is x, and we want the length of that entire side, then we would add those. So this entire side would be x plus 8. So we have the length, we have the width. So the area is equal to 2x times x plus 8. If we distribute the 2x, we have 2x squared plus 16x. Calculate the area if x is equal to 5. You can use either answer for your area. If we let x equals 5, you can go 2 times 5 times 5 plus 8, which would be 10 times 8 plus 5 is 13. And that would give us 130. We don't have any units, so I would say square units. Oh, it says feet. Silly me. So that'd be square feet. And you could also plug it in 2 times 5 squared plus 16 times 5. Either one is fine. And in the notes, you have a practice page. I will put it up here. However, this video will not go over the page. Thanks for watching.